I'll do a couple examples here using the coefficient of inbreeding equation. So remember, the coefficient of inbreeding is 1/2 raised to the n power, where n is the number of individuals between a common ancestor. I also said that you can use the number of links between the common ancestor. So you can do it either way. These diagrams are set up where using individuals makes sense because they've drawn the arrows differently than I was. But I'll do it both ways for question 1 to show you what's going on. So question 1 shows half brother and sister. So this means that if this was mom, one of the children had one dad, one of the children had another dad. So if we look at the number of individuals linking the offspring and the common ancestor, we have 1, 2, 3. So we have 1/2 raised to the third power is equal to 1/8. So that is going to be 0.125, or a coefficient of inbreeding of 12.5%. I don't care if you write them in as a fraction, as a decimal, or as a percent, as long as you understand what's going on. If we're to do this showing the links between the individual and the common ancestor, I prefer to draw it this way. We have 1, 2, 3. So we have 1/2 to the 3, which is equal to 1/8. So as you can see, it doesn't matter if you use individuals or links. You just have to keep in mind that if it's drawn this way, these two arrows do not represent 2 links, they represent 1 link because it is these 2 individuals that have the child. Number 2, this shows a half first cousin. We've got our individual at the bottom linked by 1, 2, 3, 4, 5 individuals back to that common ancestor. So we have 1/2 raised to the 5, or 1/32, which is 0.0313, or 3.13% for our coefficient of inbreeding. Number 3, we have first cousins. Now this is our example of where we have a common ancestor, we have 2 common ancestors. So in 1 and 2, we were half cousins, half brothers, half sisters. That means that these individuals were married to somebody different and had a child. These ones are the same grandparents. So they had children there, and then their children's children married and had a child. So remember, if we have 2 common ancestors, we have to take both roots into account, and we have to use the sum rule. So let's do our first root. We have the root, I'm going to draw the links. We have, if we go to individual A first, we have 1, 2, 3, 4, 5. So 1/2 raised to the 5. This is for person A. And then if we look at the other side, we've got 1, 2, 3, 4, 5 for person B. So 1/2 raised to the 5. So we have 1/32 plus 1/32 is equal to 1/16, which is 0.0625, or 6.25%. Couple more examples. Again, I don't expect you to know exactly, I don't expect you to describe what these relationships are. Some of them are quite complicated, actually. Some of them are pretty straightforward, but you just don't want to think about them. So let's look at this first one, grandson and daughter. We've got 1/2 to the 1, 2, 3, 4. So here we've got or 1/16, which from our previous example calculation is 6.25%. Question 5, we've got full brother and sister. So we've got 1/2, and we've got 2 common ancestors here. So we've got, if we go on side A, we've got 1, 2, 3, or if I draw it the other way, as I skipped the way I was doing it, we've got 1, 2, 3, 1/2 to the 3. Or if we look at our other side, our B, we've got 1, 2, 3. So 1/2 raised to the 3, which is 1/8, plus 1/8, which is equal to 1/4. This is 25%, or 0.25, 25% coefficient of inbreeding. So this one is quite high. I'm not actually going to do number 6 because I'm not going to give you one that complicated on a test, because quite honestly, it hurts my brain a bit to do it. But there are many different ways that we have to calculate. You have to calculate all the possible combinations between these 2 common ancestors. And you can see here we get 3/8, which is almost 50% chance coefficient, almost 50% coefficient of inbreeding.